There we go. All right, sorry for those of you that are waiting for the live stream. We had a little technical difficulty of something timing out, and so I had to restart us. But we're going to get started. And to start today, I want us to think about what's a function, because that's what you've been studying, and I want us to make sure that's real clear, because we're going to build on that idea today as we go through everything. So, what do you guys think a function is? What do you think a function is?
It's it's or sort of the math term is the f of x equals y or x or something like that.
Okay, that's good. We know that when we write a function, we write like f of x instead of y, right? We will say like f of x equals 2x plus 3, and we put that in place of the y's, and we do that because that way we know by looking at the equation that's up there that it is a function. So that's the way, if you see something like that where it says f of x equals or g of x equals, when it has this pattern right here, we know it's a function. Okay? How else do we know it's a function? How else do we know it's a function? Tell us what we know it's a function. Okay, and so for every x value, there is only one y value. So if I have a machine and I put the number 2 in, and the number 3 comes out, like right here, the next time I put the number 2 in, the number 3 has to come out again. Okay, it can't be a different number. All right. And so just like before, just as a reminder to everybody, just like before, we're going to be taking Cornell notes. And so this is something that you should be putting in your Cornell notes. I know it's not in Cornell note fashion up here. That's going to be your job to make sure it gets put into that fashion. So function notation looks something like this. But the definition is that for every x value, there's only one y value. So I like to use the example of if there's a soda machine, and if I push the Diet Coke button, then I get Diet Coke out. The next time I push the Diet Coke button, I get Diet Coke out. And every time I push the Diet Coke button, I get Diet Coke. Then it's a function. Or if I push Diet Coke and I got Sprite, and I push Diet Coke and I got Sprite, and I push Diet Coke and I got Sprite, it's still a function because every time I pushed the Diet Coke button, I knew I was going to get a Sprite. Okay? I just knew the machine didn't have the right things loaded in the right spot, but they were still all Sprite. If I pushed the Diet Coke button and got a Sprite one time, and pushed the Diet Coke button and got a Diet Coke one time, and the next time I pushed it and got a root beer, then it wouldn't be functioning correctly, right? And it would not be a function. So we wouldn't know every time what we were going to get. So that's the idea of this. So we have an example here, and I have a set of numbers because, remember, functions go with ordered pairs. And so we're going to look at this and see if this is a function or not. And so I put my x value of 2 in, and I got a 3. I put my x value of 4 in, I got a 7. Put an x value of 7 and got a 6. Then I put an x value of 1 and got a 3. So do you guys decide whether you think that's a function or not? Okay. Do you think that's a function that's up there? Does every x come out with just one y value?
According to that, looks like no.
Okay, why? You guys both said no. Why did you say no?
Because they're not all the same numbers for x.
They're not the same numbers for x. Okay, well, if I put 2 in here, did I get a 3?
Yes.
Is there any other place where I put a 2 in and got something different than a 3?
No.
No, okay. So based on this, the x does only have one y value every time I put it in. So I've only got x, and the only thing it ever came out with is a 3, right? So that fits that rule, doesn't it? How about this one? When I put this x in, do I always get 7? Is there anything that says I don't get 7 when I put the number 4 in?
No.
No, okay. Here's the number 7, this is my x. Is there anything that tells me something that I'm not gonna get a 6 if I put the 7 in?
No.
No, so that still fits this, doesn't it? Here, it says when I put a 1 in, I'm gonna get a 3. Is there something that says I'm gonna get something different if I put a 1 in?
No.
No. So this actually is a function.
I was looking at the mathematical equation up there, and we were drawing a conclusion of saying no. But when we look at the number 0 down, we actually see there it actually is a function.
Okay. Yeah.
So-
This
so
doesn't.
So the answer is yes.
Yeah. This doesn't go with this. But you're right. If I had an equation like this and I put this in here, would I always get this as the answer if we had a certain equation for this one? And you're actually correct. So it is yes. That's a good way to think about it. Even though this isn't this equation for this. Okay. Here's one. Let's look at this one just quickly. So I said 2, 3, 3, 5, 4, 6, 3, 7. Is that a function? Is this one right here a function?
Let me
Yes.
The second one.
Yeah, no, it's because the three is the input is put in twice.
I put a 3. I pushed the 3 button here, right, and I got a 5. So I pushed the 3 button again. So I'm supposed to get a
Oh,
5, right?
And
Okay.
and if the two would have been a 4, or the 4 would have been a 2, then that would make it not a function also.
Very good. So you kind of start to see the
Yeah,
idea
I see
behind
that.
that. Now, like on this one, I had 2 y values that were the same, right? But it was still a function because it's about the x matching with the y, not the y the other way around. Okay? So I just wanted to clear that up and make sure that was clear to everybody because that can get a little confusing before we get started on what we're going to do today. What I'd like us to do today is if you're at home, you need a piece of graph paper. If you're here, you should have a piece of graph paper. And we're going to graph this function. Okay? We're going to graph f of x equals the absolute value of x. You remember, absolute value of a number is the distance that number is from 0. And so let's make a quick little table. We can graph because we're going to use this as we do our activity today. And we're going to actually use some graphing calculators for our activity today. So we're going to choose our x's, and we're going to figure out our f of x's. So if I want f of -3, so when I write this notation like this, what I'm going to be doing is I'm going to be replacing the x value with a -3. That's what that means. Because that's usually an x there, right? So whatever letter is there, I'm going to replace that letter with that number that goes there. So I'm going to put -3 here. I'm going to put -3 here. How far is -3 from 0? It's 3 from 0, so the answer here is 3. And I'm going to let you do that for the next couple numbers here.
Do you want to scrap that one too?
Not these. This is what we're going to do. So make a table first, then we're going to graph it. Here, she can do. It's doing this one. You guys are going to do. Okay, so we're going to make this table right here. We're going to fill it in.
Okay.
Okay. And then we're going to graph it. And everybody at home should be doing that as well. this one right here.
Yeah.
Right there. All right. What are you guys doing?
So we're gonna end up, we are going to end up with a straight line across, are we?
No.
Are we?
No.
Oh, are we? So are we supposed to actually, not graph this, but draw a line on this, or
You're
just,
gonna graph like
okay.
graph the information. So this was the absolute value of x. So the absolute value of positive 3 or negative 3 is
3.
3. How about negative 2?
Oh, so this was the
Absolute value of 2 is
absolute value of 2 is 2.
yeah, and negative 2 is absolute value.
Negative 2 is 2, and 3 is 3.
Okay, and negative 1 is
Negative 1 is positive 1.
Okay.
It's just the absolute value is just the distance from 0.
yes. Okay. And so you've already told me these. So these are the points you're gonna graph right here.
Okay.
Okay.
Thank you.
Mhm. Good question. Okay, and as let's people are finishing graphing theirs, I'm going to put on my computer here. And I'm going to have my computer has to use y equals instead of using the function notation, just so you're used to that. Okay, I need to change my okay. So your graph should look something like this. And notice that it has a line that comes down from one side and comes to a point and goes to the other side. Okay? And sometimes people call this shape something called a chevron. You just heard of Chevron gas station, right?
Yes.
Their symbol is like little colored things that go like a, kind of like that
The
shape.
shell.
Mhm.
Shell.
And that's part of why that goes along with their symbol that they use. Okay? And so we're going to be looking at the absolute value function today and what happens in different situations. So this is the basic point of that this is the basic form for that family of absolute value. This point right here is called a turning point. So we want to keep a close eye today on what happens to that turning point as we do different things with the graphing.
Yeah, that is exactly what I and hopefully the rest of the class ended up with, and so this particular graph is not a function.
Actually, it is a function.
It is a function, but what I'm saying is it's not a straight line. And
Yes.
And-
It's not a straight line. line, but it is a function.
It does not pass the work, or it does pass the vertical line test, but it wouldn't pass the horizontal test.
Yeah, horizontal test is fine.
I know.
It's just the vertical one, yeah.
At least on the definition of functions, right?
Yeah, if it's a function, it's okay if they match up horizontally, but it's not okay if it goes vertically. So you're right, that vertical line test is key, and if you draw vertical lines up through here, there's no place where that line crosses the graph in more than one place. So this is a function, and so you can see functions are not just straight lines, are they? There's other kinds of things that besides straight lines. So that was a good observation to make. And what we're going to do is I'm going to give you some situations, and you have your iPads in front of you. Some people have a graphic calculator, maybe they have an iPad, or they can pull up another screen, an extra screen that they can kind of go back and forth between the Ustream, looking at Ustream and listening and trying these things. But I went to something called desmos.com. So on your iPads, if you can go online, and you may have to sign in using your student number and like you would sign into different things. So we're going to go online and go to desmos.com, www.desmos.com. Then launch calculator, yes. It's right here, DES, NOS. .com. Maybe I just type it in.
Yeah. There you go.
Okay.
Is this it?
This is okay.
Yeah.
Go ahead and push that.
Do I need the graphing?
Yeah, push that one right there.
Okay.
And it said launch calculator.
Launch calculator.
Okay.
Okay.
And push the keyboard down there so we have a keyboard. And I want you to try and put in the equation for that. Now, what you're going to do is push y equals. Push y equals.
Okay.
Y is equal to the left.
Y equals.
Sign. And then there's a thing that says like absolute value of a. So push that button. It's right close to the y.
Absolute value of A.
And then
Where is that?
it's right
Here.
there. You go now. Push up here. Push the X button.
X one.
And there you go.
Do you have that F of X or anything?
It doesn't have the f of x, so we have to use the y. So that's why I wanted to make sure we knew that this is a function. We're talking about functions, and when we started. But then we have to use y equals on this one. We can't use f of x. It gets confused on the calculator. So what we're going to do today is I'm going to ask each of you to try a couple sets of numbers and see what happens. And I want you to do them on the same set of graphs. So to get another graph on the same set of axes, up in the upper, right above here where you see the equation, there's a little plus sign.
Yeah.
Just push the plus sign. Push the plus sign. And then we want an expression. So see where it says f of x right there?
Yes.
So it's,
Oh,
okay.
And do we need to drop or write all our graphs from here down here or not?
You're going to get to kind of sketch.
I mean, they're kind of, I know they're kind of like, you kind of save them on here, take screenshots or whatever, but do we need to copy this on here?
I'm not going to have you do it exactly. I'm going to have you kind of sketch what happens.
Okay.
And we're going to use that turning point as a key thing. We'll talk about that in a couple minutes.
Okay.
So don't change, just so we can keep them all in this whole set on the same set of axes so you can see what's happening. Because change what's happening in the equation, what happens to the graph, okay?
Okay.
That's why I want them all on the same set of axes, and then I'll let you kind of sketch it on the page you have.
So pretty much this is science terms, but the dependent variable on this would be the f of x for the y equals the absolute value of x, and then the independent variable would be the whatever or the input would be whatever value or number you would put in.
Yeah,
right?
good, and that's like your x value. So your x, you're right, is the independent variable, and the f of x is your dependent variable. I like the way you tied that to science. That is terrific.
Yeah.
So those of you at home, I had sent you an email that said that there was a set of problems for you to kind of work through and try in the doc sharing. And those of you here, I've got a paper for you to look at. So if you haven't pulled off the doc sharing at home, you have to do that right now. And I want you to try to, using your graphing calculator, to enter each set one at a time, and each set gets to be cleared out. After each set you clear it out and try the next one. But what I need you to do is, once you've got the set and it's done on the graphing calculator, kind of sketch. You're going to, number one, sketch what you see on the graphing calculator. You don't have to be perfect, just kind of sketch so you have an idea. And then look at the equation and the graph and the patterning in the graph, and tell me what you see happening. How is the graph and what's happening on the graph related to what's happening in the equation? So I want you to stop and think about that when you're doing that. So go ahead and plug those in for set A and see what kind of pattern you can find in the relationship between the graph and the equation.
So what value do you want to put in?
I've already done this one, so
It's right there. Okay.
okay, and then once you've got that, note the pattern down, and then try the next one. And we're going to do that for a few of these, and then share out the patterns.
So it's gonna be more than this one.
Yes.
And if you give a microphone privileges, the students on the other end of sort of the phone line can talk, right?
Yeah, there is a way for them to type in answers, things like that, but they have to make sure they sign in a certain way.
And does that particular iPad have like sort of like a text to speech app or whatever on it?
We're not worried about that right now.
Okay.
Yeah.
Good. So they're all right here.
Yep. So look what happened. What did you do here, and what happened here? Where's your turning point? So the key thing is look at what's happening with the turning point.
If everyone did this correctly, they should have ended up with the expression or the turning point or the fulcrum of -4.
Oh, how does that relate to your equation?
It is it relates in it relates as in the independent variable you put in was 4.
It was positive 4, but the point came out at
-4.
Huh. Did you see that too?
So that's because you put in the absolute value.
Okay, I want to make sure everybody's hearing that.
So
So I'm going to hold on for just a second. One of the things they noticed here is that for the very first equation after the absolute value of x in set A is that it said absolute value of x plus 4, but the turning point ended up at -4. So let's see if that's the same pattern for all of those in that set. So go ahead and try the rest of the set.
yeah, I'm sorry, but if you put
Yeah. There just don't have to be the understand, just click the plus sign, the little plus again, so you can enter another equation.
yeah, I'm just saying if you put in the value for -4, the answer is positive 4.
You think so?
Yes.
Okay. Oh, you changed it and you did plus a -4 and you ended up with positive 4. So try the rest of these and see what happens.
Yeah. That's what I'm
Okay.
gonna do. I think I'm good. I think That's
we're
gonna
going to
make me end up with a negative
We're gonna add another equation
-3, -6, and a negative 7.
Okay, so try it and see what happens. See if your guess is
Okay.
correct.
Okay.
Are you seeing, what do you see, noticing working?
I'm almost there.
Oops.
Okay, now, and it still goes through 3, but it ends up with a straight line. Oh. Oh, okay. Yeah, you're right. My mistake.
It's okay.
Yeah, I know. But
It's
anyway.
easy to fix. That's why we're using the calculators instead of having to try and do it by hand. You want to try it? So can you jot down your patterns you found for doing that?
Yeah.
So how to write down, just make it
I
like in your
can't
notes.
do that.
No. What happens when you have this kind of a pattern? When the equation has this kind of a pattern,
Write it on here or on here?
and in your notes. You can write it on here if you want to. Write it in your notes.
The on my phone on the Cornell notes. Okay. The note pattern.
Yeah, so write down in your notes what the pattern is you found for this set.
Alright, in these notes, yes. Okay, I'm gonna do that or that. X plus 3. Yeah, now it ends up right.
Okay, good. So let's put another one on there. So let's do another one now. So what's the next one?
Okay, I'm gonna jot it down in my notes here. So we're gonna end up doing 8 today.
We're gonna end up doing, I don't know if we're gonna do all 8 of those, but we're gonna have several of those. So,
Okay.
one of the things we found here in the classroom is that when
Oh,
you
we're
have
supposed
a
to do it
specific
on
pattern.
there. Okay. Okay. Yeah, I have notes. And I have to, or I want to put in my graph. Okay. Ready, set. Okay, here we go. It just has to be a sketch, right? Yeah, I know.
Okay, so what we found is that first set, the pattern was f of x equals the absolute value of x plus some sort of constant number, whether it's positive or negative 3 or that kind of thing, but that number is inside you're adding the positive or negative number inside the absolute value sign, right? That the turning point moves to the negative value of C. So if C was 5, point moved to -5 on the x-axis, right? We have to say on the x-axis. I should say on the x-axis here too. So that's a pattern we found. So let's try the next step.
When are we gonna get to the essential question?
We're gonna
Get to that?
get to that. We're gonna
Okay,
summarize it all
okay.
together at the end.
Okay,
Yeah, I forgot to, I didn't get it up there on the board, but that's okay. We're gonna,
we're gonna do that later.
and And we're actually kind of doing the process of that essential question right now, because the essential question is gonna be, what are the patterns? What happens to the absolute value sign as we make different changes in that pattern?
And you're thinking of the copies of those notes, you're
Yes.
thinking, right?
Yeah, absolutely.
And
You're all right, let me write that down. Why don't you go ahead and do this, and she'll get that copy down for you, and then we get copies, okay?
it's a put in input, put in input, get, or it's gonna be put in input, get an opposite output.
She actually wrote it down first, and then write down what she wrote before. Okay, so just when you
Okay.
get to your next set, don't worry about that.
Okay.
Okay?
Yeah.
Just put, here, do this now.
Okay, yeah, but,
Here,
okay,
go to
work
set.
on my set.
Yeah, on your next set.
Work on the set C. Okay. Okay, I'm sorry, I already started. That.
Okay, so we need to clear it out.
How do you get the calculator for?
You can clear it up as special cases.
But how do you get the calculator? Oh, here it is.
Yeah, there's a little
button somewhere
button
on the
that is a
keyboard.
little keyboard down the corner of this.
Okay.
So
Okay,
Y
here we go.
equals.
The Y,
Mhm.
well, the absolute value, X,
Mhm.
X
Okay.
plus, the number,
Oh.
which is,
Actually, it's plus 4 on the outside of the absolute value this time.
okay, set B,
So
we're on
let's
set
go
B,
back
so.
then. So let's go X, and then we have to, let's
Okay,
get X, and we want to get outside of the absolute value, so I push the arrow here.
Yeah.
So now put plus 4.
then, plus,
So what happened?
4,
Okay.
and then
What did it do this time?
it
Let me
ended
erase
up on,
this for you.
it's the same, pattern or the same lines, but it's it's on the Y axis, and it's at 4.
Oh, they
Oh.
went straight
They went straight what direction?
down,
They went up or down, didn't they?
down.
Okay, so where's the constant number this time?
So it has a, negative,
In terms of
or a
absolute value.
positive slope and a negative slope.
It still has that positive and negative slope, good. Okay, but where's the constant, the number this time? This time it was inside the absolute value sign, this time
Outside.
it's outside, and when it's outside the absolute value sign, what did you notice?
They went down,
It moved up or down the,
line,
which line is that?
line.
The y-axis, good.
Yeah.
Try, put another one in and see if that's true.
I got exactly what
Okay.
what you found the board.
So one of the things that was noticed here is for the next set in the pattern, this was set A, this is set B. I'm graphing absolute value. And the pattern is, and this time we're adding the constant outside of the absolute value sign. Here the constant was inside the absolute value sign, here it's outside the absolute value sign. So when I do that, example up here. you'll notice that as I pull this down so you can see, that this time the turning point moved up and down the y-axis, and that the constant value, that the 4 and the 7, is outside of the absolute value sign.
I did the rest of the values for
Uh-huh.
set B at least, and I figured out that whatever in this section, whatever number you put in is where the fulcrum of the is where the fulcrum or the pivot point of the kind of the seesaw ends up.
Mm-hmm. On the which axis?
On the y-axis.
On the y-axis. Good. So when the graph of the absolute value and the pattern is f of x equals the absolute value of x with that constant number outside of the absolute value sign, or the c is outside of the absolute value, the turning point moves up or down the y-axis, and it moves to the exact point that c is, right? This one, it was the opposite of what the c was, right? So if c was positive 5, it moved on the x-axis to the negative 5. Here, if c was 5, it actually moved to 5, didn't it? Okay? So that's the next pattern. All right? Yep, erase the, except for the absolute value of x, which is the straight absolute value of x, and then try another one. See what happens.
How did we do 1/2 on the?
Mm-hmm. Just do it one way or two. Or you can't try it. Okay.
I thought it was right this one now as well.
So, write down what patterns you found. Okay. And then try the next one. So once you guys, I want everybody to do the next 3 sets on their own real quickly and see if you can find the pattern. Then we're going to share out in the last couple minutes what those patterns are, so we have all those patterns to help us as we move forward.
Yeah, I just want to say that for this formula for this particular function, it seems like it always ends up with like a sort of a teeter-totter pattern.
Yes, anytime you have the absolute value sound like that, you are going to end up with that kind of pattern. You're exactly right.
What is the one the slope is 2, and the slope is 2. If that's what
The slope on that one is 2.
we're somewhere. Alright.
That one looks like the slope is 1.
Oh, yeah, you're right. Slope is 1. So that means every box, if the students did it right, that every box or every line or all say, if you start on, the points are where, I think where you, for this percent, see if you put in the formula still sort of stays the same, but if you put in different values, or different values, the fulcrum or the pivot point of the, like the teeter totter is going to change, but the slope is also going to change. Yeah, slope has, no, the slope has changed, the angle of the line changed a little bit. Okay, I agree. There we go. Yeah, there we go.
Okay, so what happened here?
The angles of the lines changed.
So the lines got
Yeah.
steeper, you say?
They got,
It's the slope.
they got steeper, so then
It's the slope on that.
the slope now is now it's the 2/1, so 1/2.
Yes, no, it's 2/1, so it's, 2 is on top and 1's on the bottom.
2.
So it's 2. Wow.
Yes.
You notice anything about your equation with that?
So yeah, the value it told me to input on this one is it is, we don't have a y intercept, but we still do, but so the value the input you put in, it determines the output, but I still don't understand why we put it at 0. Maybe that was kind of the value in the iPad or the calculator app put, or the site put in for y.
Yeah, are you talking about the turning point?
Yeah, the turning point.
Okay, remember here the pattern?
Yeah.
It was +4, -3, -6, +7, that's where it ended up on the y, right?
Yeah,
If there's no number there, what number is it?
0.
Yeah, so you didn't have to put the 0 on there, it just knew.
So, and I assume that if I can do this right now, but I don't think I need to. But if you put in 0 for x, I think it's gonna stay the same. But if you put in 0 for x and another number for y, it's gonna stay on the line. But whatever value you put in for y, the turning point is gonna end up right there.
Yeah, when the pattern is this way, you're right. When it looks like this,
Yeah.
this tells you this
Or
goes up or down, the y-axis.
When on this particular function.
Yeah, on that particular function, what happened? It didn't move it up or down, it made it what? What did it change on that?
It changed the y value. It changed the pivot point.
Did it?
Actually, no, it didn't. The x,
Try another one, put another one in.
the x value.
Put another one in.
Okay, are we?
Yeah.
Yeah,
Did you get all of them?
we are. So
Okay, so you have a pattern for each one? Okay, good. So I'm gonna ask you to predict what you think this one's gonna look like without, don't put it in the calculator yet, okay?
When I
That's okay, come on in.
we're supposed to predict
Yes,
it,
the
correct?
reference word.
So when I predict when I put in the 3, the pivot point is going to change to up here.
Think about your patterns, take all the patterns you use, and see what you pull together for that.
Yes,
it.
yes, the slope changed, the x, the x and y values didn't change, but cause that's the number for the slope, we would need to put in a y, a b, but the slope changed.
Yeah,
or
so
the-
I didn't put it intentionally, because I wanted you to see that the slope was changing.
Or the slope of the line changed, or the steepness of the line changed.
Okay, so
So those are very descriptive words.
very good. I'm glad you used those descriptive words. Why don't you try this one now? Try a couple of them so you
I'm
can see.
gonna try set D.
Okay,
Sit down.
okay. Think about the different parts. What does this part tell you?
All I'm gonna have to do is,
Go positive 3 and then down negative 3.
No. Oh, think about the different pieces we've got. This part here, if we didn't have this, what would this tell me to do?
I'll go up 4.
Go back and think about it. Look at your patterns. And think about what each pattern did.
Make it negative and then
Negative on the,
on the x.
uh-huh. This would tell me to do,
Positive.
no,
Negative
negative on the,
y.
yeah, so, and then, so I'd go over to -4 and
Down 3.
down 3, and then,
Up. And then go
so your turning point is at,
3.
right? Here's your turning point, that's the point where the point is. What does this tell me? Look back at your pattern. Find one that matches, and we can try it again.
okay, or this one, this one is very similar.
Mm-hmm.
So yeah, it's very similar. So, but sorry, on mine, I'm noticing on the first part of set D, if I have the 2 negatives, I should have a plus right there.
Yeah, so I
but-
just put one negative on there, what happens? I only want one negative.
Oh. Yeah, for right now, okay.
Put one negative.
Okay,
What happened?
if you put in a negative, it should reverse the direction of the lines, but the steepness should still stay at 1.
Very good. Okay, so let's summarize everything now that we've talked about. Okay? So
Okay.
the first thing we did is we said we were adding or subtracting something inside the absolute value sign, it moved the turning point on the absolute value to the opposite of what's there. So if it's at +4, it moved it to -4 on the x-axis, right? And we said that in the notes. Then we said, what happens if we added or subtracted outside the absolute value sign? And we said that moved it down to exactly that place on the y in the y direction, didn't it? So we moved it to the -4 because it said +4. We moved it down to -3 because it says -3 on the outside of that. Then you said, what happens if we put a number in front of the absolute value sign? So we're multiplying. And what did it do?
Made it down a bit. Not open.
It's open to, the opening is up, okay? And it made, what happened compared to this line, it made it,
Small.
okay, the opening's more small because the lines are, let's think about math terms. How do we describe this line?
The blue one or the red one?
The red one.
The cube?
That's the angle. Let's talk about the line. Compared to this line right here, this line is what? If I'm looking at this line compared to this line is what? Is it the same as this line?
Yeah.
It's which hill would you rather run up? If you had a choice between this hill and this hill, you had to run it. Which one would you rather run?
Just one.
Why?
It's easier.
Why?
Because it's not as hard to remember.
Why not? What's the word that you can use to describe those two? If these were hills, what word would you use? One is steeper, right? So putting the number up front made everything steeper. Exactly. Okay, and then if I made that a -3, what would it do to it? It would make it do what? And if I put a negative in front of the 3, what did it do? What did it do? It flipped it upside down, didn't it? Okay. So those are the things that we need to do. I'm going to write that down and let Mrs. Arado get herself set up ready to go. Okay? So we'll write those summaries down, and then we'll be done, and she can get set up and ready to go. I just got to stop my recording. And so hopefully everybody has taken some notes on that, and go from there.